So at the top of your page, if you can write our learning goal, I'll type it for you. Okay, so we're talking about all the bisectors today. So segment bisectors or perpendicular, and then also angle bisectors. So please write that down, our learning goal. So to use perpendicular bisector theorem and angle bisector theorem to solve for missing variables. Okay, so on your paper you have, this is a little reference for what a perpendicular bisector would be. So remember, perpendicular means it is going to intersect, lines that intersect at 90 degrees. I'm just going to make little notes on the paper and you can do that as well. And then bisect, hopefully you remember, that means to split or cut in half. So a perpendicular bisector is a segment that is going to be splitting my other segment or side in half. So if I look at this picture here, if I'm going to identify which line my perpendicular bisector is, it's going to be line CD. And I'm just going to highlight that. I know this is a line because it has arrows. And I would write that as line CD, which is written right here. Remember the symbol for parallel is right there, that upside down T. So once we know this is a perpendicular bisector, we can tell, or we can figure out this is a perpendicular bisector by the right angle. I'm going to highlight that as well. So that tells me perpendicular. I'm just going to do that little symbol there. And then my congruent marks tell me that it is bisecting or splitting in half. Okay, so that tells me the congruent segments, if you can even see that symbol there. Okay, so once we've determined that that's my perpendicular bisector, the perpendicular bisector theorem, or just like the rule that goes along with it, tells me that it is equidistant, so the same distance from the endpoints of the segment. So wherever you are on this line, so for example at point C, we know it's the same distance to A as it is to B. I could pick any point along this line, here, 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 here. It's going to be that same distance away. And you don't have to draw this, but if that were my figure there, that would be the same distance, and so on and so forth. So once I know that is the same, or sorry, once I know that is a perpendicular bisector, I can mark my other two sides congruent. So this is actually an isosceles triangle because I have two congruent sides there. So I'm just going to finish typing here. So that would be AC is congruent to, and I'm just going to do an equal sign since I can't do congruent, is going to be congruent to CB. And that is our perpendicular bisector theorem. Okay, same thing. The converse just means we can read that backwards or flipped. So when the statement is flipped, it is called the converse. So same thing. If we know that these two are congruent, that means that this line is the same distance, A is the same distance to C as it is to B, then I know that this line is my perpendicular bisector. So we just write everything backwards. So I'm going to mark this as my perpendicular bisector. And then I'm going to copy this statement down here, just writing it in reverse. So CD is perpendicular to AB, and AD is congruent to DB. I'm not going to copy that down here, but go ahead and write that down. I'll pause the video while you do that. Okay, so here we have some examples where we're going to actually solve for the value of x, or we're going to solve for x, just using our perpendicular bisector theorem. So we can tell that this is a perpendicular bisector because of my congruent marks and because of the right angle. We have to have both of those things. I'm going to write that down. So we want to check for right angle, and we know that it's a right angle by the box, and then also my congruent marks, or my congruent dashes. We want to see both of those things to determine it's a perpendicular bisector, and now I can go ahead and solve here. So if that is my perpendicular bisector, then I know that these sides are going to be the same. Okay, so away and away from the perpendicular bisector, those are going to be the same lengths. So think about where I'm putting my equal sign if these two are congruent to each other. Okay, so I've set that one up for you. Oh, maybe not. And from here, it's just our regular algebra solving for an equation, solving for x. So I'm going to go ahead and solve for this one by subtracting 7x from each side, and then I'm going to add 48. So you can pause the video here and try this one before I go through the answer. Okay, so I've put up the answer here and shown my whole process of how I solve for x, but you should have ended up with x equals 12. So once we do that, we can see that there are some similar to that. So number 3 is the same as number 1. Oops. Oh, that's not the highlighter. So number 1 is the same as number 3, and number 6